In order to prove this theorem, if an arc of length s subtends an angle theta at the center of the circle of radius r, then s is equal to r theta. That is, the length of the arc s is equal to the radius of the circle times the angle theta, which is subtended at the center of the circle by the arc. Let us consider a circle of radius r, and it subtends an angle theta radians, and the length of this arc is s. Let us label this as O, A, B. Let us also draw an angle AOC, which is equal to 1 radian. And the length of this arc is equal to the radius of the circle r, since it has an angle of 1 radian. So let us write this down. Angle AOB is equal to theta radians, and arc AB, the length of the arc AB is equal to S, and radius of the circle OA, which is equal to R. Then we drew an angle AOC, which is equal to 1 radian, and the arc AC is equal to R, because it has an angle of 1 radian. Therefore, the arc's length is equal to the radius of the circle R. So, for all we know that the length of the arc of a circle is proportional to its subtended angle. So therefore, arc AB is proportional to the angle AOB, which is theta radians. Arc AB is proportional to angle AOB, and also arc AC is proportional to the angle AOC, which is 1 radian. Arc AC is proportional to angle AOC. Taking ratios of these two equations, we get we get arc. So we get AB, that is arc AP divided by arc AC, which is equal to angle AOB divided by angle AOC. So value of AB, which is this, is S, and value of arc AC, which is this one, which is R, which is equal to angle AOB, which is this one, which is theta radians divided by angle AOC, which is 1 radian. So when we cross multiply this equation, we get S is equal to R theta. Note that in this equation, theta is always in radians. Theta is always in radians. So hence we have proved S is equal to R theta.